Okay, let's go ahead and take a look at your problem. So your problem was this one here. So the classes you wanted to do, you kind of said, oh, this is the lowest, and you want 20,000 as your width. So you started with 70,000, and then you did plus 20, 90,000, 110,000, 130,000, 150,000. Is that it, or is there more? One more. 170,000. Okay. And then you work backwards to find these guys. So here's the deal. What's my data in? Is my data rounded to the nearest thousand?
No.
If my data was rounded to the nearest thousand, then I'd go 89,000. Everybody see that? If it was rounded to the nearest thousand, but it's not. My data is rounded to the nearest what?
Ones.
Ones. So there's dollar. Everybody understand that? See, I have some 130,273. It's rounded to the nearest dollar. That means I need to take this and find the thing that's $1 less than it. What's $1 less than this? 89,999. Does that make sense to everybody? So, find out what your data is rounded to. It's rounded to the nearest dollar. Then you need to take this and go $1 less. Everybody see why? Because here's why. If I didn't, is it possible for me to have somebody have an income of 89,374?
Yeah.
Where would it go?
Nowhere.
It can't go here. And because it's too big for that and it's too small for this, it would have nowhere to go. You know what I mean? So that's why, since your data is to the nearest dollar, then you need to do that. This also to the nearest dollar, and you need to make this. Is that everybody on board? Does everyone see why? Because you need your data. If it can be whole dollars, you need to have places for them all to go. Like this 139. Oh, there's that. That's not a good example. But yeah, there's spots where things would have nowhere to go if you did it the other way. Or they could have nowhere to go. 109,999. So I'm just going to add 20,000 to each one of these, or I'm just going to subtract one from the one before. The last one I can't, so I'm just going to add 20,000. Each one of these is separated by class width. Boundaries are all there. Everything's magically there. Let's go ahead and check your answers. Give you guys a minute to do that. Frequencies. I think you could have gone, like I said, 60,000 to 80, 80 to 100. You could have done that, 60, 80, 100. Especially since we ended it with, it would have ended with 179,999, so it would have caught everything. So if that would have been, probably makes more sense. I didn't do that. Everybody got the relative frequency? This is what you guys got for your frequencies, yes? And then relative frequency, 2 out of 25.08. This one, 3 out of 25, 12%, 0.12. Cumulative frequencies, just add the everything in that class and what came before it. So 9 plus 11 is 20. Now, take a look at this. This is how Jim Hannon would have you do it, right? My guy who actually did statistics for Lawrence Livermore Lab, right? For real situations. Pretty clear, easy to see. This is how your textbook This is how I taught it for 2 years. It's how the textbook wants you to do it. Like that. So then you end up here like with a class from 141,668 to 100,589. That is just a lot less clear for me to wrap my head around. Right? Like these throw me off a little bit, right? You know what I'm saying? So that's why I mean, I really have to agree with him that the way we're doing it now is a lot better way of doing it.
I have a question.
Yeah.
What about rounding your data so that it's more readable? Like instead of going to this nearest single dollar.
Yeah, that could be something you choose to do. I didn't really give people the option in this case. You could possibly do that. Yeah, so that's a little bit clearer.
Right.
Yeah, so you could round it to the nearest 1,000. I think that's often what they do. They round the data to the nearest 1,000. That's super common. Yeah,
Okay.
and that would be a judgment that you would make as a researcher. Yeah, and I think that what he's saying is, when I take my data that I have and round it to the nearest hundredths. So where is it? Here's all my data. Is round all of them to the nearest thousandth to start off with. So then we have all our data in thousands. And I think it's a lot clearer for people. Like it's easier to wrap your head around 130,000 to 146,000, right? As opposed to these weird extra decimals. Or not extra places. Okay, good. Now we're going to move on. Outliers. Outliers are extremely high or low value when compared with the rest of the data values. So, for example, here most of our data is 0, 1, 2, 3, 4. There's like a 5, a 6, a 7, no 8, but then there's a 9. And then there's a big gap. No 10s, 11s, 12s, 13s, 14s, and 15s, and then there's a 16. That 16 is an outlier. It's kind of out there on its own all by itself. So that's what an outlier is, the idea of it. Extremely high or low data value compared to the rest of the data values. Histogram. Ria, go ahead and read.
The histogram is a graph that displays the data by using vertical bars of various heights to represent the frequencies of the classes. Class boundaries are represented on the horizontal axes for continuous data.
Right, so histograms, there's like 3 or 4 different ways. They're all good ways of doing histograms. It's really very fluid in terms of how people do it. But the one thing that's consistent is your X values or your data values and the numbers that they could be are along the bottom. So class boundaries or class limits, something like that. And your frequencies are always how high they are, always. Right, so that's a histogram. So this is a discrete one, so there's no boundaries. And see how they're not touching? So siblings, you can have 0 siblings, 1, 2, 3, 4, 5 siblings. Right, everybody on board with this part? And they're totally not touching. Theoretically, I'm going to be okay if you kind of wanted them, if you want to use the boundaries instead. So what's the boundary between 0 and 1?
Half.
Yeah, 0.5. So if you put 0.5 in there, what's the boundary between 1 and 2? 1.5. Everybody on board with me?
Yeah.
If you kind of use these boundaries down here. And then, if you kind of did your histogram using that, so then my histogram would look like this. Oops. And have them all touching. I'd be okay with that because, like I said, I'm going to be really flexible about this one just because there's just so many different ways of doing histograms. And it's really kind of, they're all correct. So it's kind of, it's quite a bit vague here. So here's an example though. So this was my example from the second page that we did. 2.2, the bottom of page 2.2 down here. If you look at that data. Well, here, I'll show you. So here is my data. Here's my table that I created, right? And the simplest, easiest way, because I am all about simple and lazy and not writing as little as possible, is I just use the boundaries. So I use all of these boundaries, and then I have to use the last one as well. So if you look, I'll do 99.5, 104.5, 109.5, down to 134.5. That's these guys right down here. They're all right in there. Those are all my boundaries. 99.5, 104.5, 109.5, 114.5, all the way down to 134.5. All my boundaries are along here. So my first class has boundaries between 99.5 and 104.5. That's my first class. How high is my first class? It has a frequency of 2. So I'll go up 2, just like that. My next class has a frequency of 8, maybe? 8. And then 18. So that's from here to here is my second class, frequency of 8. Good. Third class, 109.5 to 114.5 has a frequency of 18. Good of that class. Right, that's this one right here. 109.5 to 114.5, frequency of 18. So from here to here, you've got that. Now, you could also, if you wanted to, see my class limits is 101, 100 to 104. I could just write that in if I wanted to down below. 100 to 104. This one would be 105 to 109. But then I got to write twice as many numbers, and that's a pain in the butt, so I don't want to do it. So that's why I just do the boundaries. You can do either one. Notice, if you do it this way, it should be directly, this should be directly below this. If you do it with the boundaries should be on the edges, from here to there. From here to there, those should be the edges of this box. Good. So either one's fine, depending on how you want to do it. Theoretically, these wouldn't touch because you don't have anything from 104 to 1.5, but I'm not even going to care about that anymore. I think it's, people have argued me out of, people I respect like Jim Hannon have kind of argued me out of that, being that important. So, but we'll keep it simple. So what I'd like you guys to do is do lab problem 3, make a histogram of your frequency, of that frequency distribution below. So if you didn't do it the way we all did it, do it this way for this now.